Hi, Mr. Richmond, and this is your Unit 8.5 lesson summary. In Unit 8.5, we'll be analyzing and interpreting data. So we'll be taking a look at all the different types of data we've seen, talk about what measures of central tendency are the best to use for different situations, as well as introduce you to one last graphical method that we can use to represent data. So the last graphical method we want to talk about is our stem and leaf plot. Okay, the way stem and leaf plot works is we'll have a kind of a holding place for all the 10 digits, 10, 20, 30, 40, and then we're going to branch off from there little leaves that represent each number. You can do two different data sets at a time using a stem and leaf plot, which is a nice use of it. So I'll try to do that first, and then from that we'll talk about what measure of central tendency would be best to use for this particular data, and then I'll just give you a couple rough examples of different data types so you can see the different distributions and how that helps me decide whether to use a median or a mode. So we have the ages of the different actors of the year and actresses of the year from the years of 1999 to 2005. So in 99, I believe it was Russell Crowe at age 40, and etc. different ages for different years. The person who won Best Male Actor in 2000 was 36, 47, 29, etc. And then over here we have the female ages. And so what's nice about a stem and leaf plot is I can actually plot both these pieces of information on the same graph fairly easily and kind of see a comparison between the two. So let me show you how to make a stem and leaf plot first. We want to see what digits we need first of all. I don't really have anyone in their teens, so I don't really need a tens place, but I do see 20s, 30s, and 40s. So I put the main 10 digits down the middle first. Okay? And in your more classic stem and leaf plot, which I'll start by showing that, it would look like this. And if I had 10s, I'd start here. If I had 5s, I'd have a 5 and continue on. And for every one I have, I put that number to the right of it. So I have a 29 here for the Best Male Actor. So I'm going to put a 9. Since I have that once, that just tells me that 29 was in my data set. Then I move into 30s. My lowest 30 is a 6. So I have a 36. Since I only have it once, I only put the 6 once. I also have a 37 and a 38. So I need to put a 7 and a 8 as well. Okay? That's it for my 30s, so now I can move into my 40s. I have a 40, a 43, and a 47. So to represent the 40, I put a 0. To represent the 43, I put a 3. To represent 47, I put a 7. So it's just a much more condensed method to put all my different numbers. So I can look at this if I understand a stem and leaf plot and say my numbers were 29, 36, 37, 38, 40, 43, 47. Okay? And just like that, nice and easy, I can see all the numbers in the data set. So there was no repeat numbers here. Now, if you want to put a stem and leaf plot that has both on there, then you can put a line on the other side, title it so you don't get any confusion as to which one goes where. So this one was my male actors' ages. So I'll write up here, male actor ages. And I can go the other way and represent the other data as well. So let's do that. So my ages going the other way were 25 and 28. So going the other way, I need to include 25 and 28. So I'm going to go 25 and 28. And as long as I remember that the stem, the main part, is where I use my 10 digits, and these represent the single digits go with the number, we're okay. So I have 25 and 28. For the 30s, I have 30, oh, I also have a 29, almost missed that. So 25, 28, and 29. Then I have 30, 33, so 30, 33, and then I have two 35s, 35, 35. So I can put a number twice if I have it twice. And so again, now I can see all my data. 29 for male actors, 25, 28, 29 for female. 30, 33, 35, 35 for female. So I'll go ahead and label this one as well. Okay? And just like that, I can see all my data. And I don't have any 40s, it looks like, for the female, so I got everything here. And I can start to make some generalizations that I might not see with other data methods. For the females, they were all in their 20s or 30s. Every person who won the Actress of the Year was in the 20s and 30s. So the older actresses weren't really winning it in the female category. Whereas in the men, 29 was the youngest. There's only one person that young. The men tend to win it more in their 30s and 40s. So older male actors tend to win the award, whereas younger female actresses tend to win the award. And with the stem and leaf plot, it's a little bit easier to see that. I can also tell what kind of data I have. Okay, it's a little harder to see in this method, but you can see that that's roughly symmetric. As this one, you might not think is as symmetric. It looks like the majority of them are pulled off to the right, but it is a little tougher to see with that. So we can look at other stat plots like stem and leaf plot, or dot plots and box and whisker plots to get a better idea of the distribution of it. Okay, so what should I use? Mean, median, mode. How would I find that from this data? Okay, let's find the mean of this data first. So the mean is found by adding all the numbers up and dividing by the number of numbers, so that doesn't change. I'm still going to find that by doing, let's do the male, we'll do the females first actually, it's on the left. 25 plus 28 plus 29 plus 30 plus 33 plus 35 plus 35 over the number of numbers I have, which was 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And I can get my mean. Okay, I'm going to grab a calculator so I can add that up real quick. Add that up, I get 215 over 7. So my mean is 30.714, so we'll say 71. So that's the mean for this data. I can also find the median for the females by putting them in order and finding the middle number, but they are in order the way I have them here. So as long as I count off okay, we'll be all right. Since there's 7 numbers, I'll do 3 in both directions. So 25, 28, 29, 35, 35, 33, making our median 30. So you can use stem and leaf plots to get your mean and median. Now, since my mean and median are so close together here, 30 and 30.71, that tells me that the data is probably symmetric. So that kind of verifies the fact that the data is likely symmetric. Okay? And when data is symmetric, it's a good idea to use the mean and standard deviation. So for the women's data, it'd be better to use the mean and standard deviation. That is kind of always the case. If your data is symmetric, then the measures that are the best to use in those situations are the mean and standard deviation, okay? Because they're so close anyways, and the mean will give you a little bit more accuracy in terms of finding outliers. Now for the males, you can find the mean as well. Add the numbers up. 29 plus 26, 29 plus 36 plus 37 plus 38 plus 40 plus 43 plus 47 divided by 7. We add those all up real quick. Speed this up for us. 29 plus 36 plus 37 plus 38 plus 40 plus 43 plus 47 is 270. Divided by 7 gives us our mean, which is higher, which we kind of expected because it looked like more males were winning the award in their later years. So 38.57 was the mean. And I can find the median as well by looking at the data and counting off. So my highest is 47 and 29, then 43 and 38, then 40 and 37, making the median 36. And in this type of data, it kind of depends on how it's distributed to just determine which one is better. But since this data to me looks like it's skewed a little more, since the data is skewed, I would probably use the median and the interquartile range would probably be the preferred method, because you can see that the mean's been pulled away from the median a decent amount. And although it is a little tougher to see with a stem and leaf plot, we can look at dot plots and other plotting methods to kind of maybe see that a little more clear. But by calculating the mean and median, you can also get a decent idea of what to use. Now, just to add to this, now that you kind of have an idea how a stem and leaf plot works, we know that we should use the mean and standard deviation when the data is symmetric, and we should use the median and IQR if the data is skewed at all. Why don't we try a couple last quick ones to make sure we understand that process. And I can show them to you a few different ways. So for example, here's a quick dot plot. So in this dot plot, the data is skewed to the right, because the majority of my data is on the left-hand side. And a lot of us have trouble with that. Why is that skewed right? I mean, it looks to me like more data is on the left. Why wouldn't you call it skewed left? Well, your median would tend to be right here in this zone, but your mean is going to get pulled away towards these higher values. So since it pulls the mean to the right, it skews it right. And when data is skewed right, you should use the median and the interquartile range. Okay? Now, let me show you that data in a slightly different way. Let's look at it as maybe a box and whisker. So when I look at this box and whisker, more of the data is over here. Okay? Shape-wise, it kind of look like this, because it's more lumped over here. This is now skewing left. Okay, why is this skewed left? Well, your median is in this zone, meaning that your mean would be pulled away from that by some of these smaller values. Since it's pulling the mean left, we call it skewed left. And once again, since that mean is being affected in that way, it's not really going to be as accurate of a number. So I should again use my median and my interquartile range. Okay? Now, if my data, and I'll use a histogram this time, if my data is more symmetrical, okay, as I look at this data, it's fairly symmetrical. Majority of it's right there in the middle, and it's pretty balanced on both sides. When data is symmetric, then it's okay. Mean is now a pretty good number. I don't have anything skewing it away. My median will be in the middle, and my mean will pretty much be in that similar spot in the middle. So if that's the case, then we should use our standard deviation and mean. And so you need to be able to look at all the different data displays that we've dealt with in this chapter, tell how it's being skewed, whether it's skewed right or skewed left, and know how that affects your mean. Okay, skewing left pulls the mean lower, makes the mean lower than the median. Skewed right pulls the mean up higher, making it bigger than the median. And if your data is symmetric, then your standard deviation and mean should be pretty close to each other. What does that mean as far as what we should use? What measure of central tendency should we use? When it's symmetric, use your standard deviation and mean. If it's skewed left or right, you should use the median or interquartile range, since it's less affected by that. Okay, that sums up the chapter. Good luck with the test, and I'll see you next time.